broadcast is now starting. All attendees are in listen-only mode.
All right, good afternoon, everyone. A warm welcome to the first webinar co-organized by Nanyang Polytechnic and Manicon Academy. Our topic for today is Understanding of Corneal Topography. My name is Corinne, a lecturer from the School of Health Sciences, Nanyang Polytechnic, and I will be the moderators for today's webinar. We are very happy to have over 600 colleagues from more than 10 countries joining us for this session. This is a great proof of the fact that there are no boundaries for continuing lifelong learning. Please allow me to start off by providing everyone with a brief introduction to the two organizers of today's webinar. Our main organizers, Nanyang Polytechnic, is a leading institute of higher learning in Singapore, where School of Health Sciences offers a diploma in optometry course for the training of optometrists. Not limiting to the grooming of the younger generation, our institute also greatly supports the effort for lifelong learning. Manicon Academy, the co-organizer of this event, is an initiative by Manicon Singapore with the objective of improving the skills and expertise of our fellow eye care practitioners. With the current COVID-19 situation, both of the organizers sees a greater need to support fellow eye care practitioners in their continuing education. As such, we have come together to offer continuing education training through webinar sessions like the one today. We hope that you will be benefiting from this session. And now allow me to continue on to provide you with some housekeeping information before we start the session proper. During the session, all participants will be mute during the presentation. If you have any question, please use the question tab to send us the questions. We will compile and invite our speaker to answer them at the end of the lecture. Over here, there are actually two screenshots to show you where you can actually go off to, okay? Right, it can be via the app or if not via the web version. You will also need to fulfill a 75% completion of all the following criteria to be awarded the e-certification of participation for this session. You have to be present throughout the whole webinar and respond to the poll questions that was raised during the webinar. You will also need to complete the quiz questions in the link that will be provided after the webinar through an email. Please note that the link to the feedback form of the webinar will be sent to all participants via email after this session. Please complete and submit the feedback form. After you have submitted the feedback form, you will receive a link to the webinar quiz. Click on the link and complete the quiz. Submit the quiz and you will receive a message for you to have information with regards to our second webinar that is actually in June. Please do note that qualifying participants will receive the e-certificates in 2 weeks' time after you have submitted your quiz answer. For Singapore participants, please note that this webinar is still pending OOB approval for the CPE points. We will keep you updated when we receive confirmation. Without further ado, please allow me to introduce to you our speaker for the day, Mr. Zender Sturck. Mr. Zender is an optometrist based in the Netherlands. He started his optical career in 1995 by following several educations about optics and contact lenses. In the year 2005, Zender graduated with a Bachelor of Science as optometrist. During and after this education, he works in several big contact lenses companies in the Netherlands, where he did a lot of autokeratology. Currently, Zender is working for Manicon Netherlands, a manufacturer and developer of custom-made lenses. He is closely involved in the development of new contact lenses and is responsible for training and workshops. Furthermore, he continues to feed contact lenses in practice, which is frequently seen in his lecture, which takes on a practical mindset. So now please allow me to hand over the time to Zender, our speaker for the day. Zender, please.
Thank you, Corinne. Thank you for the nice introduction. I have to pick up my slides. Yep, okay, here we go. Give me 1 second. And yeah, okay. Then everyone, welcome. And of course, thank you for Manicon to create the opportunity to do this lecture. But again, welcome to everyone. If I see the amount of attendees this morning, it is huge. And especially if you realize the fact that when I'm at home, no one is listening to me. So it feels like a real honor that so much people take time to listen to my lecture. And one of the reasons I think this lecture is quite popular is because it has everything to do with corneal topography. Corneal topography is is and will become more and more important in our lens practices, and probably we all realize that. The other side of it is that we most of us are not schooled in corneal topography. We all buy such a device, it's placed in our practice, and in short terms, they learn us how to switch it on, how to switch it off, but that's it. And that's why most of the time, if we talk on seminars or so about corneal topography, it's a quite popular topic. So also today I like to discuss with you that we all get a better understanding of corneal topography. What Corinne already mentioned is quite a practical approach. So we can go very in the theoretical part, and sometimes I will do that, but always with a practical approach in mind. My goal at the end of this hour is, or 45 minutes, is that we all have a better understanding about corneal topography. When we enter tomorrow our practice, we look different to our topo maps. We know which button and where we're looking at, and how do we reach our goal. So that being said, there are a couple of things what I like to cover this morning. And one of the things is why should we do a topography? But that's the red line in that's the red line in my lecture. Why should we do everything? So that's a question I ask myself all the time in practice. Why should I do this? Why should I do that? And if you ask yourself the question why, you keep learning. So again, why should we do it? Why should we do topography? Well, one of the main reasons for that is that we want to gather as much as possible information. And the topographer device is well giving us the possibility to gather that information. We get so much more information of the eye that we can look different to eye shapes. We start learning from topography, and in one other thing, we start thinking different about lens fitting, but that's later on. I put on my webcam again because I think talking to you is more personal. So getting as much possible information as possible. Well, what a simple example of that is we can look on corneal shapes. What we see here is a kind of deformation of the cornea caused by a silicone hydrogel lens. We call it a warpage in the Netherlands, but maybe in your country as well. But it's a deformation of the cornea caused by a contact lens. If you look to the right side, this is a perfect example of a kind of measurement you like. Just perfect, beautiful curved shapes. And if you compare that to the left one, it is very irregular. These kind of things, we can get a better understanding how the patient's eye look like when they enter our practice. And before we fit lenses, we can do so much more already before we even place a lens on an eye. And that's what I want to cover this topic. Another thing is that topography, what I already mentioned, is helping us to fit lenses with a new philosophy. And yes, we all fit lenses by K readings, and people who already see my lectures about the C-night lens, they are already knowing that I'm really believe in the fact that we have to not use K readings anymore. We have to look differently to lens fits. And again, that's in the beginning stage. There are not much lenses out there with that philosophy, but that will change in the future. So it is quite important. It's very important to understand topography because it will become more and more important in the near future. So that being said, a bit more explanation what I mean with a different approach about lens fitting, another philosophy, fitting philosophy. Well, we have to look to a design of a contact lens, and if we see a normal contact lens, we have in the center area we have an optical zone, and then we have an alignment zone, and at the end we have an edge zone. That's in a rough vision. That's how our design of a lens looks like. But the fact is that the alignment zone, that's actually in every contact lens the place where the lens actually hit the cornea, where what we call the point of touch. This is the area what will fit on the cornea. So if you have an idea that if you have your map and you only use the center area for the K readings, but in fact the lens is fitting in a total different area, well, we do a very rough estimation. We are guessing more about the fit than we actually fit the lenses. So what we're doing these days is fitting the lenses on K readings in the center, and we work our way out. And our approach is we have a topographer. A topographer provides us with more information of the periphery of the eye. Well, use that information, so start from the outside and work your way back to the inside, so that we actually start with the fit, the actually fit. So that's why it is important that we really start learning and about corneal topography. People who already fit the C-night, they already fit these lenses with the new principle already. But this is a kind of principle which not only for orthokeratology. You can use this for soft lenses, for scleral lenses, for GP lenses, rigid lenses. So it is a total different approach of lens fitting. And again, we are starting now with the ortho K lenses in case of the C-night. If you use the C-night, you're working with just the periphery. Your fit is more accurate. But in the future, we will probably add up other lenses as well. Well, that being said, corneal topography, how does it work? because it's good to understand what we are actually doing in our practice. Of course, we know all the placer discs. We know it. We've all the topographers, all the reflection topographers have a placer discs. We know how to turn it on, but most of the time that's it. But what are we actually doing? Well, if we see all on the eye, all the circles, they are the place of the disc are projected on the eye, and these circles are perfect. They're perfect circles. We put it on the eye, but we create reflection, and the device, the topographer device, is getting the reflection back. But because the eye is not perfectly shaped, all the circles will a bit change. It's not a perfect circle anymore. It's a bit deformed. So the topographer device knows the difference. Okay, this is the circle, the perfect circle I project on the eye. This is what I get in return. Well, this is the shape. This is the difference. So this is the shape of the cornea. In this case, we see an astigmatism with the rule. And the topographer shows us several things. And one of the things is that he shows us K readings. And fun fact, K readings, yes, we all rely on that these days, but in the future it will become less and less important for our lens fit if we just start using other fitting philosophies. But that's a future thing. But again, it is important to already understand it. Another thing, what some topographers showing you are p-values. E-values, eccentricities, well, is something if you look more into lens designs and fitting perspectives, E-value will become less important as well. But again, that's maybe something to explain in another topic, in another webinar. But for now, we can do something with e-values as well. Some topography shows our pupil size as well, and there's something I have to mention about it. And keep in mind that the pupil, some topographers doesn't measure it, some other don't. If you have a topographer who don't measure it, well, you don't miss anything because it is quite unreliable. One of the things is you are looking into a light bulb. The rings will turn white or red. It depends on the topographer you have. So there will be much more light on the eye. So it will contract the pupil size. On the other hand, is and you already know it if you sit behind the topographer, I try to accommodate on the place of this. It won't work. It won't happen. It cannot accommodate because it's too close. So it will become small and big, and it will affect the pupil size as well. So in my perspective, the pupil size is quite unreliable in a topography measurement. You have other tools for that in some topographers. Then there's another thing. Red means steep. The redder it is, the steeper it is, and the more blue, the more cold colors, the more flatter is the eye. And you will see that I use a lot of Medmont images in this lecture. Why? Well, it's worldwide the most used topographer. That's for sure. But it is the topographer I use in my own practice as well, and that's for me the main reason, because I use a lot of images what I gathered in my own practice. But every topographer have in common that when it is red, it is steep, and when it is blue, it is flat. Yeah, so you can always translate it to your own topographer. Beside that, let's look about two a bit different topographers and the measuring range. The size of the area of the cornea, what is measured, that depends on topographer. On the device, and let's assume that we start fitting in the periphery, or let's say we start fitting ortho K, and we fit ortho K lenses quite large on the cornea, around 90% of the cornea. It covers 90% of the cornea. So if you really want to fit in the periphery and you want to use the data, you need a topographer what is actually measuring that area. So there are a couple of topographers are doing that, and for me it's difficult to call brand names right now, because I know already that brand names in other countries have a different name than we have here in the Netherlands. So I don't go into that. But there are a couple of topographers, most Scheinflug topographers, of Scheinflug cameras, I have to say, but 2 or 3 topographers. The majority of topographers measure a bit less, and that isn't a problem. That isn't a problem. We can calculate, we can extrapolate the data out. We have so much, we already have for around 20 years topographers in the Netherlands, and we already have 20 years experience with calculation about it. So we can really can do a good calculation for the missing rings. So if you have a topographer like this, no, well, not a problem at all. Most of the topographers are the with a bit smaller measuring range are the topographers with a bigger cone. So your head just almost disappear in the cone. And those are the topographers. And what's another thing to mention is that you, if you don't move the head position correctly, you miss even more. So, and then it will become difficult because we have to extrapolate more and more. And the more you extrapolate, the more you assume something. And the more you assume something, the more chance for mistakes. So what we are trying to do is, okay, if you have such a topographer, no problem, he will measure perfectly, but make sure you try to measure as large as possible. And I have a quick tip later on in this lecture how to solve that. And there is the old school topographer, the older ones. We start to replace them already. They only measure this area of the cornea, and we have to extrapolate that much. We have to assume that much that they, for the new fitting philosophy, will start probably in a couple of years. Then, well, they are not reliable for that. So again, if you in this lecture and thinking about buying a topographer, make sure you get one of these 2. And honestly, if you buy a new topographer, most of them are in this section already. Those are the cheapest one, the oldest one. So most of the time, the second-hand ones. And well, if you buy it for the future, stay away from these, in my perspective. There's another thing I learned a couple of years ago, and I want to share with you, because the measuring range depends also on the curvature of the corneal surface. And this is a bit theory, but I think interesting to know, because it lets you look differently to your topographer as well. Let's say we have an eye and we have a topographer. So what you see happening here is I try to create in my best PowerPoint skills a topographer. But just to explain what is actually happening, what is a topographer measuring? Well, I heard stories in the world that a topographer is measuring the height of the cornea. And that's absolutely not true. Absolutely not true. A topographer is measuring a tangent, because we are measuring a reflective surface, and you can only measuring a reflective surface when you're measuring a tangent. And a tangent is just a straight line. And what a topographer is doing is looking for his tangent body. So let me explain it a bit better. If you feel tomorrow or this afternoon in your own topographer, you will see that it is not a real circle. There are only every white and black part is a straight line under a different angle. So it is everything is angled, and the only thing the topographer is doing is looking for his tangent body. So okay, I have this angle. Which angle is it on the eye? So if we put it on, and the light bulb will hit the measuring device in the center. The only thing what a topographer is doing is this. It's only measuring, okay, what is my tangent body? And you can imagine that how flatter the eye is, that this tangent body will more in the periphery. But then a steeper eye, you will reach that tangent, specific tangent, what corresponds with this tangent over here, by a steeper eye earlier than with a flatter eye. So the curvature of a cornea depends, is also responsible for the size you actually measure with your topographer. This image shows also the fact that if we do topographer, we have to do topography in complete darkness. And why? Well, you can imagine that if there is a light bulb over here and it reflects in the eye as well, the topographer is, well, sounds rude because it costs thousands of in euros, thousands of euros, but it's a very stupid device. It only say, okay, I put some light source out and I want to get it back. But if you have light bulbs on in your room, the light, maybe the computer screen or just lights spots above the head, and it's reflecting as well, it will also enter the measuring device, which causes a problem for the topographer. He cannot decide which light ray to use, so you will end up with mistakes, with false measurements. So it's also important to do your measurement always in complete darkness. And a good example of that is this. This is from an Oculus topographer, and what you see is in the center, it's wrong. You see it's a relative flat eye, but in the center part, it's steep. Well, then you can think, okay, whoa, it's a kind of nipple cone. It is not. It's just a mistake made by the topographer. Because in the center, there's the measuring device. In the center, honestly, is the camera as well. We paid such an amount of money for the topographer that we want to see, want the situation that we can see behind the device what is actually happening. So there is a camera there as well. So in the center area, the topographer is actually not measuring something. It is just completely blanco. So it is interpolating. So we can extrapolating, but the topographer is interpolating. It's calculating back. And again, if you have light bulbs on and there are too much light rays, he get confused and he assumed maybe the wrong things. And if you assume something, it's, well, there will happen mistakes. So again, in the center area, a topographer is actually measuring nothing. And if you realize that, it's funny that we still use K readings when we use a topographer. Because in fact, we are not measuring the K readings, it is simulated. And you will see it in your topographer as well. You can probably see it quite, E is sim K, simulated K readings. The topographer is screaming to you, I just calculated, I didn't measure it, I just calculated, I did something. The topographer is very great in measuring the periphery of the eye. Some people said to me, okay, this is for an Oculus, this is only working for the topographers with a larger cone, and that's a wrong assumption as well. Why? This is from a Medmont. It got a smaller cone. It's almost pressed in your orbita, but you will see that as well. You see, if it's a perfect red spot or a perfect blue spot, that's strange. Yet it screams to you, okay, this is something you cannot rely on. You have to do it over. So again, completely darkness, then you will prevent that as much as possible. But it will happen to you, but be aware of that. Okay, another thing is to remember, garbage in is garbage out. So if we don't take the time and if we don't put the effort in creating a good topography image, what do you expect then? Let's say if you try to fit a C9 lens, what is, by the way, the Ortho K lens we have from Manicon, it's based on the new principles, on the new fitting philosophy from the outside to the inside. I have a much higher success rate. It's a much safer approach, but that's definitely for another topic. But it's a safer approach in Ortho K. But when you just don't put enough effort in creating good topography image, what do you expect then from the end result? So a lot of people think, oh, now I have a very expensive device. I press the button and the top device is doing everything for me. Well, no, it's not happening. You are still the specialist. You have to decide, okay, which topographer map is useful and which is not. So again, garbage in is garbage out. So that's bring me to the point how to create then better topography images. And that's an important thing, because what we're measuring with a topographer are the tangents, but we are not measuring the tensions from the eye itself. We are from the cornea. We are measuring the tangent of the tear layer. We need a reflective surface, and the cornea itself is not reflective. So the tear layer makes it possible. And what we do, and that's the assumption as well, we assume that the tear film is exactly the same shape as a cornea. That's what we do. That's where the principles where topography relies on, reflective topography. But if you look to this image, and I make it a bit bigger. If you look at this image and you look into the inferior part, the lower part, you will see that the circles are not perfect circles anymore. No, there is a huge tear meniscus, and that will affect your topography map. It will affect your topography. You will see it back in your topography map. So that's the reason we have to be really careful, put much effort into the good topography. And when do we see huge tear meniscus? Because we see it a lot in topography, and the reason for that is because we don't let people blink behind the topographer. Most of the time we are quite busy with the topographer, but just with ourselves to have the points or on the right spot or how your topography is working. We are just ignore the patient at that moment. But the patient is not knowing what is happening. So they want, let's say they want to order lenses. Okay, they're a bit excited already. Okay, then they have to go with the chin on the chin rest. Okay, then there is a big cone. Their head just completely go into the head in its complete cone. Then you put it on there, red lights or full of lights. Do you really think that the patient's still blinking? No, it's just not going to happen. So it is important that we remind the patient to blink. So you have to learn to talk with your patient during the measurement. So that you say, okay, blink a couple of times. Okay, stop blinking so you can do the measurement, and blink again, and you will see that you will end up with much more better topographer maps. That's for sure. But the second, the fun thing, what you experience as well, the moment you stop talking to the patient, the patient will stop blinking. It's for sure. Try it tomorrow, you will see it. So it's important that we still interact with the patient to prevent this. Yeah. So, and that's what I see a lot happening in practices. People just, let's say in a rude way, we ignore the patient. Of course, we're too busy with ourselves. Yeah. So I think it's time for poll questions then. What I will do. I will create the following. The question is, which topo maps are useful in your practice? And I will close it so you have a better look. And the options are over here. And have 20 seconds, have a look, and then I will turn up the poll so you can vote. And then we can see on live what the vote will be later on. But for now, there will be a very pleasant moment. So I will shut down for 20 seconds so you can have a look to the question. And then I will launch the poll. Why now? Because in practice, you don't have more time to make decisions as well. Okay. I wait a bit longer because the votings are still going on. But what I see here in my screen, and I will share with you in a moment, is the fact that we are not agree about this. We have very, very different answers, and that's okay. That's very good. Okay, I will wait till 75%. Okay, I will close the poll right now. And let me share with you the results. What was everyone thinking? And what we see is that 56% say, okay, we have to use image B and D. And well, that's the majority of the people what think, the half of the participants. The other ones say, okay, A and B, or B and D was it, and B and C, and 70% said none. Okay, well, let's say we hide the results. We are back now in my lecture. Let me close the poll. What is the correct answer, in my opinion? because we can argue about everything. But in my opinion, the best answer was D, none. You have to use none. And again, let me explain you why. And there's the why. I think that's quite important. Why? Well, what we see here several topo maps. We see A, B, C, and D, the one from the question. And we see that several images, they are not looking the same. B and D looks the same, but what we suggest to do by topography is doing more topography measurements at once. So only doing one measurement and rely on that, it's not useful. Keep using your Jafal keratometry, but don't use topography then. Topography is only reliable if you do more measurements and compare them first. So what we suggest to do is do four measurements and compare those 4 measurements. And if those 4 measurements are the same, well, perfect. Move on. If they are not the same like this, you have a problem, probably a tear film problem. The tear layer is not stable enough. So what you see here, this only 50% of the measurement is, well, looking like each other, but it's not enough. We want the majority. So if you have this situation, a quick tip is use artificial tears. If you use artificial tears, you put them in the eye, wait for a couple of minutes, depends on the drop you're using, but around 5 minutes. Well, if you need a lunch, use gels, but then you can lunch in between. But otherwise, if you use drops, just wait for 4 or 5 minutes and do the measurement again. And you will see that you end up with more stable measurements. And then you know, okay, we assume that the tear film is the same as a corneal, as a shape as the cornea, but because every measurement is the same, I can make that assumption. So that is really helping creating better topography maps. Yeah. So again, that was the answer. If I measure four measurements and 1 is off, I go on with the other 3. But if there's already 50% is off, I have a tear film problem. Just first solve that and do the measurement again. Okay. Then, what I already mentioned, head position, quite important. What we have, and then I mostly talk about the larger cones, the majority of the topographers out there with larger cones. Be aware that in case if you measure the left eye and you put it on, the nose can be in the way. So if that's the situation, you will end up with the nose, what is missing. And we can argue and we can discuss about the superior part. If you have an eye what is too deep in the orbita, there is no way to get the superior part. But the nasal part is something you always can measure. And if you don't measure it, you didn't move the head as much. If you want to measure, for instance, the left eye, you have to turn the head to the right side, so the nose is not covering the light bulb anymore, and it will result in a better image. So if I see images where the nose part is missing, I know, okay, the specialist fails. It's not a topographer, it is you as a specialist. So make sure that you just get a head position. And sometimes you create strange situations. If the patient's with a chin on the rest, you have to put them in different strange situations. But again, the patient wants a good help. The patient wants good lenses. So we have to make that effort to create a situation that we can calculate with the right information. Okay, then about maps and scaling. And there is a second poll about it. Let me show you the poll. And the poll is following. Which eye is the easiest to fit a lens? In which eye can you better fit a lens? And take a moment. I will be quiet. And I will launch the poll. Wait a couple of more seconds because the voting is still going on. It's quite active. So, okay. And I wait for 75% again. And then we stop. Okay, I will close the poll right now, and let's look to the answers. It's an answer I really already expected, that the majority of the people, almost half of the audience, say, okay, I want to use number one. Third part say, okay, I want to use number two, and 27% say, okay, I want to use both. But I want to hide the results again, and I will go back to my lecture. And what is the correct answer then? The correct answer is both. You can use both. And this is a misleading question, but it is also to be aware of the fact that we are looking to the same eye. It's exactly the same measurement. Look at this part. It's just the shape here. It is exactly the same measurement. The only thing is the map I choose is one is a sagittal map and the other one is a tangential map. So it's the same measurement, but the topographer is representing the images completely different. So what is actually happening? Why is the topography doing that? And what is happening? Interesting to have a better understanding about that. And there are several ways to explain this, and I think this way for me is working. I can explain it the best, and you can with it have a very mathematical approach, but I want to keep it just as simple as possible, because then I understand it myself. What is happening? If we look to the sagittal map, the beauty of a sagittal map is that we can look very good to shapes. We see directly this is a corneal astigmatism with a rule. It's just obvious. These are shapes we are schooled to recognize, so we are used to it. But what the topographer in a sagittal map is doing is everything relate to the sagittal of the eye, so to the center part of the eye. Normally it's the center is a bit, the sagittal is a bit off, but for now, for the explanation, I put it really in the center. So everything is related to the center. So if you say, okay, I have to say something about this point, but I have to relate to that point, what is the kind of curvature I need to connect those two? You can imagine that if you want a part more in the periphery of the eye, say, okay, but it's the sagittal map, it's still the sagittal map, I have to relate everything to the center part. So what kind of curvature do I need now? And you understand that this should be a flatter curvature than from this point to this point. And that's what you actually see happening in this topo map. You see it flattening in the periphery, which make it more kind of a power map. Kind of power approach, and that's the reason if you use this for autokeratology, you can use to the center of the treatment zone is very beautiful, very perfect to look on in the sagittal map. So this is very interesting. Another thing is if you look to the tangential map, and that's quite interesting because now. I'll explain something to forget. It's a bit of a rough it's a rough way to show the cornea. Let's say we go all to the mountains together. We have such a great time right now, and we say, okay, the COVID-19 is gone. We go all together to the mountains on holiday, and we enter the mountain and say, okay, the steeping percentage is 10%. We don't know where the steepening is. The whole road could be flat, and the last part could be very steep. In total, it will be around 10% steepening. So it gives some information, but not real information. If you look to the tangential map, it's a very valuable map. You see, it's very irregular, and we cannot, we see a kind of astigmatism, but it's not so clear than in the sagittal map. What is the topographer doing now? Well, for your information, now the topographer is looking very local. With other words, it is not taking into account the sagittal height anymore, the center part of the cornea. It brings nothing in relation with the center part. It is only looking on where is the tangent. So what is the tangent of each point? And for your information, you think, oh, but the eye is curved. Yes, the eye is a kind of curved, but in every curve, let's say a circle, even a circle is built up and made up out from straight lines. So let me explain that. If we have a circle, it is a kind of curvature, but if we magnify it, if we zoom in, there is still a curvature, but less. And if we even more magnify and more, you can imagine that the more you zoom in, the flattening, the curvature will become flatter, flatter, flatter. And in the end, you will end up with a straight line. And that straight line, that's the tangent. Yeah, and he's looking for that. And he's showing you that. So everything is very localized. So if we go to the mountains then altogether, and we see a kind of roadmap, then you can see, okay, it's not a steepening of 10%. This is where the steepening takes place, and where we go back down, and where the steepening is again. So we have much more information. We have very localized information, and that's the exact reason we use the tangential map so often for ortho-K, because we can see very much in the periphery what the curvature will be. So again, quite important map, and I hope if you turn back tomorrow to your practice, you know what each map is using. Yeah, very useful in a keratoconus eye as well. But again, we don't cover that in this day. Then another topic, relative and absolute. Of course, you can have a map. We can have a sagittal map, and we can have a tangential map. We can have elevation maps, all these kind of maps. But now we focus ourselves on sagittal and tangential maps. But you can look to them in different scalings as well. Well, what do I mean with that? What you see over here is a central astigmatism. Is a corneal astigmatism with the rule in the sagittal map. And what the topographer is doing, if we look to the relative scaling, and for the top MapMont users, it is the normalized scaling. What he's doing is, okay, this is from an oculus topographer. These are all the colors I can show you. I have no more colors to show. This is everything I show you. But in this image, the steepest part is 7.0, and the flattest part is 10.0. So, and what he is doing, it is adjusting the scaling to the image. Let me give you another example as well for exactly the same. This is a corneal astigmatism with a rule as well. But the scaling, well, the colors are in exactly the same order, but now the steepest part is 6.2 and the flattest part is 9.2. So what you will see is that the scaling is adjusting itself to the image. So interesting to understand is that when you go to the absolute scaling, so now we leave the relative scaling and we go to the absolute scaling, and I use exactly the same images, I only switch scaling, we end up with a totally different image. What we see over here is the same eye, what we see before, but now we see it's more green and it's more red about over here. What is the absolute scaling doing? Well, the absolute scaling is telling to you, okay, these are the order of colors I can show you. I have no more to show. These are all the colors. But beside the fact that these are the colors, these are the maximum values I can measure. So 3.8 is the steepest part I can measure. I cannot go steeper, and 34.5 is the flattest part I can measure. And what you see happening now is that the image is adjusting itself to the scaling. So to keep it clear, in a relative scaling is the scaling adjusting to the image, and in an absolute scaling is the image itself adjusting to the scaling, typically the opposite. And both are useful, both of them are useful, but you can better use the bottom one in your practice most of the time. Because this is only useful if you want to compare patients with each other, several persons together. What we are doing when we are testing lenses, we have different results, and we want to see, okay, what are the steep eyes, what are the flat eyes? But we in our practice have dealing with just one patient in our chair, and you want as much as possible detail in your image, and that's what this map is showing you. So the best setting for your topographer is in the sagittal map and the Medmont users are, it's called axial. In the relative scaling, or for the Medmont users, they call it normalized scaling. These are the best settings for your topographer. And of course, from there on, you will move and you will maybe do other decisions. But if you start in this, you have as much as possible information for yourself. These are the images we are using in EasyFit as well, our software. So if you see that your topography image in your topography is way off than we show in EasyFit, probably it has something to do with your settings. Well, call your management subsidiary and ask them to help you how to solve that, and they can help you with that to set the settings good in your topographer. Or otherwise, call the distributor of your topography. They can do it for you as well. Yeah, okay. Then the last part I like to mention because of timing as well, recognizing patterns. And of course, this is quite easy, quite simple. What we see here is a spherical eye, and this is a toric cornea. Very obvious, and that's what we see. The fun thing is, if we have a poll question that refers to the question, let's do the question. If you have this eye, it shows up in your practice, and you will fit a GP lens, a rigid lens on this. What will happen with the centration of the lens? That's the question. So first take a couple of seconds to look at it, and then I will show you the poll. And I will launch the poll. Here's it. Okay, we're almost there. And I will close the poll, and let's share the results. And what we see is the majority say, okay, we'll go superior. The other part will go say, okay, we'll go inferior. But those are the most to what was chosen by everyone. And let me hide the results. And let's go back to the lecture, because what is the correct answer? Correct answer was B, the superior centration. So the centration will be superior. And why? Well, there's a rule of thumb. A rule of thumb is that a contact lens, every lens will fit in the periphery of the eye, but will center to the steepest part of the eye. And that's what you see. And half of the people who's attending so see, okay, well, it's going superior. Here you see the beauty and the power of a topographer. Before fitting any lens on the eye, you know already what the behavior will be. So that's very important to understand. That's a really, really valuable tool of a topographer. So get you used to do more topography. Let's say we put a lens on the eye, it will go superior. And on this eye, actually, I put some lenses. And this is a lens, it will be superior. And this is be superior as well. And the fun thing is, a lot of people call this a high riding. And honestly, I'm arguing with that, because I learned at school that a high riding is something when a lens is decentered. But in fact, in this case, the lens is exactly on the place it should be, because the superior part is steep. This is the best place for the lens to fit. So in fact, it is not decentered. Well, the patient will be satisfied because you are looking to probably the border of the optical zone, but in fact the lens fit is perfectly. What you will see happening in these cases is that people with all the tools, they try to center the lens with prism ballast or flattening, larger, smaller diameters. They will do everything to get the lens centrated. But ask yourself, if you are doing that, are you really respecting the cornea then? And that's something to think about, because we have to respect the cornea. And this is we know beforehand that this will be the case. So, or manage the expectation of the customer, or make maybe another decision. Say, okay, I have to go to soft lenses in this case, or we give it a try and do something else. But again, you know the information up front, and I try to prevent to do. By all means, try to get the lens centrated, because I don't respect the cornea anymore. I want to stay away from that. Another thing is, of course, if you look to toricity, of course, we have a with a rule and against the rule. We already see that before, and I don't have to explain that much. But there is one thing that we living in the optical world, and we have in the optical world names for everything. And let's explain you this. These are all astigmatisms with the rule. They look different. So if they look different, we call them different. Just to keep things simple, we in our lens practices in our optical world, we have name for everything. But what we see here is the fact that we have a central astigmatism, but we have it also in the periphery. And in comparison to this one, we have in the center area an astigmatism, but in the periphery, there is almost no astigmatism left. So that's what we call this a limbus to limbus astigmatism. And the other one is central astigmatism. And if we go back to one of the first slides where I mentioned, okay, but keep in mind that the fitting philosophy in the future will be different, that we still more fit on the periphery. Well, maybe you have to make different approaches in the lens fit. You could end up with a situation that the astigmatism in the center area is the same, but the periphery is different. So if you have a center astigmatism the same and you keep it with a normal spherical lens, probably you end up with a good fit. But here it will be decentered, it will not function properly, because it actually fit in the periphery, behavior will be different. So very important stuff. We don't cover it even more today, but for other lectures maybe it's interesting stuff to go into. Another thing is that we have to deal with irregular corneas. This is what you will see in the majority of the time as well. This is what you will see most often, that the superior part is steeper than the inferior part. We also have an irregular cornea with the opposite, that the steeper part is in the bottom. And one thing, my experience is that a lot of people, colors are really afraid if they colors and they see this, I have to deal with the keratoconus. Well, again, when Baba Papa got just ahead, keep breathing. It's just an irregular astigmatism. Yeah. When it starts to dent over here inside, then it is a keratoconus suspect. So as long as Baba Papa got just ahead, just keep breathing, and you have to deal with an irregular cornea and move on with your lens fit. Yeah. The fun thing is, if you fit lenses on these, already imagine what is happening. You say, okay, well, this lens will go superior, this one will go inferior. But this is, in theory, this is the case. You will see that the lens will go inferior. But in practice, it will go superior. Because there is a mismatch with the fit, so the upper eyelid will have control about the situation, and you will end up with this situation. I have an example of that. This is the situation where when I put a lens on the eye, what you will see happening is that the upper eyelid will have a grip on the lens, and will take it upwards. And this is what I should call definitely a high rider, because you expect it downwards, and now it is upwards. So this is a real high rider, and you have to manage this, because otherwise you deform the cornea. You will end up with a warpage. You will see that there's a lot of fluorescein over here because the eye is steep over here. So that's one thing. I have one small topic to mention, but we are almost out of time. So I will close my session now. And I want to ask you if you guys have any questions, yes or no. And my screen will turn back to the screen of Corrine. And I will just wondering if there are any questions here. So still quiet. Everyone asleep. Or everyone is gone. Could be the case as well.
Hi, thank you, Xander.
Ah, yeah, okay.
Okay. All right. Okay, Xander.
Okay, yeah.
Yeah, so here's our questions. Okay.
Yeah.
All right. So for the first, because we don't have much time left, so I'm just going to restrict ourselves to 3 questions.
Yeah.
And hopefully we can keep within the time. All right.
Yeah.
So the very
Yeah.
first question, all right, is axial the same as tangential?
Sorry, again, is?
Is axial the same as tangential?
No. Axial, in case of the map mode, then you are really mentioning the map mode, that the axial map, I will turn on my camera. The
Yes.
axial map is the sagittal map. And
Right.
the tangential map in a map mode is just tangential map. For me, I don't know. Ask me. I don't know why. But several brands have several different names for different things. But tangential is very common. It's quite the same everywhere. And when you start to talk about sagittal map, one use relative, one use sagittal, and the other one used axial. So that's very. But axial is sagittal.
Right. Thank you for your very precise answer. So
Yeah.
how about question 2? When we use EasyFit software on a residual power patient after AutoK wear, the EasyFit will flatten the base curve most of the time.
Yeah.
How about the set height? Should we adjust the set height without adjusting the base curve? Please advise. And which method is better? Manually adjust the set height or follow EasyFit decision by using the flattened BC?
Yeah, I understand. This is really an ortho-K question, and we are now in a topography session. But in 2 weeks, I will give an ortho-K session as well. So maybe it's perfect to cover that in the ortho-K session. So it's already a bit teaser, and we have already one attendee then, because I think we have to postpone that question for that session.
All right, that's great. So we'll postpone this question to the next session then.
Yeah, well, I think that's better because it fits more in the topic then, and to explain it right now just by mouth is too hard. So then I can show you that by examples.
That's great. So for the participants who actually raised this question, please join us on our next webinar so that you can get your answer. All right. So our last question here: would tilting the head affect the topography results?
Again, sorry.
Will tilting the head affect the topography results?
I don't get the real question. Okay.
Will tilting of the head affect the topography results?
Sorry, I don't get the first part of your question. Sorry, this is very stupid, but.
Okay. Will head tilt affect the topography results?
Will heat?
Head tilt. Tilting
height,
of the head.
The height.
Sorry. Tilting of the head.
Oh, the tilting of the head. So here we are.
Yes.
No, so okay. Of course, tilting of the head is improving, especially when you have someone with eyeballs deep in the orbita. You can what you can do, the chin rest, put it higher, so you get the high up, the head up, and of course tilting. Do everything what is necessary to get a situation that you have as much as possible information, that you cover with the pleasure of this as much space of the eye, because the more you have that situation, the more information you have, and we less have to assume something. And the moment you have to assume stuff, there will be the mistake. So if you have to tilt, if you have the patient upside down, do it, but just create good images. Yeah.
All right. Thank you for the answers.
Absolutely.
So okay, we are a bit tight with time, so we will actually stop our Q&A over here. And thank you, Xander, once again for the very insightful lecture. We have learned a lot. All right. So please allow me to thank you. So please allow me to a couple of minutes to just do some reminders and housekeeping before we end this session. So please take note that. Sorry. Yeah.
No
problem. So please
give me the opportunity to say hi, then I mute myself to say bye to all the participants. Thank you for joining, and I hope to see you in 2 weeks. Then we talk about ortho-K. Bye-bye.
Yes, I'll see you, Xander, in 2 weeks. All right, so back to our housekeeping. All right, please note that the link to the feedback form of the webinar will be sent to all participants via email after the session. Please complete the feedback form and submit it so that you can actually access the webinar quiz to actually work on it. And after you actually access the link for the quiz, please complete the quiz, sorry, and submit the answers. You will receive information to our next webinar, which is actually in 2 weeks' time. So let me just give you some updates about our next upcoming webinar. The next webinar that we will be working with Xander also is actually to talk about autokeratology and some case studies with regards to that. The date will be on the 11th of June 2020, Thursday, and in Singapore time, 3 p.m. At this time, all right? So once again, thank you everybody for attending this webinar. Thank you to Xander for the insightful lecture, and I hope everybody have a good time today, be it in the morning or be it in the evening. Thank you.